Afternoon, everyone, and welcome to the AWS Networking Leadership Session. I'm Dave Brown. I lead the EC2 compute and networking teams. We're not going to cover too much of my compute business. We're going to be focusing on the networking business today. So we've got a lot to cover, so we're going to go relatively quickly and look at a couple of things that have happened in the last year and some of the features that we've announced at reInvent this year. So let's dive in. So I'm sure you've seen a few of these slides this week at reInvent, talking about our customer base. These are a lot of customers that we work very closely with on the networking side. There's a broad set of customers, from startups to enterprises, public sector, ISVs. I'm sure you recognize many of the logos that are there. AWS, we continue to be the market leader for the 8th consecutive year. Obviously, the compute and networking businesses have a large part in establishing ourselves as the market leader. Some of the surveys that happen, so this is the Gartner Magic Quadrant that gets published every year, and then you can see Amazon Web Services continues to be sort of in the top corner of the leaders quadrant. I also see that the market is sort of consolidating. There's fewer players in the market now, but AWS is still leading. And then the same thing with IDC and their survey from a leadership point of view. One of the reasons that we believe we are the leader in the space is how we run our business. And as you guys know, everything we build comes from a request from a customer at some point in time. And I'm sure many of you have had meetings over the years with Amazon and provided feedback. I'm hoping that some of that feedback you may have given us on the networking side you see in the products that we launched at reInvent this year. The networking business continues to grow. If you go back to reInvent 2012, we literally had just launched VPC about 2 years prior to that. We didn't have, we had a single load balancer. We had very few of the services that are on this slide today. And now we've built out that slide. Elastic Load Balancing has 3 services, 3 different load balancers. API Gateway provides you with API functionality. CloudFront continues to grow. You'll see that a little later in just how they've built out their edge locations. AWS Private Link we launched last year at reInvent. That's proven to be incredibly successful with customers, and we'll dive into that a little bit deeper. And then obviously Route 53 and Direct Connect. One of the things we always talk about when we're thinking about what features are we going to build, and obviously got the feedback from customers, is we think about how do we support more workloads in the cloud. And by workloads, there's different things that customers want to do on EC2 or with the network. And so what we're really looking for here is a network that can support the world's workloads delivered through continuous innovation. And that's another principle is we'll launch something and then we'll continue to get feedback from customers and continue to iterate. And so the structure for the talk today, we're going to break it up into a couple of sections. Looking at the broadest scale and high availability, giving you some background on that. Diving into some security, always an incredibly important topic for us across the business and especially in the networking space. Looking at some of the improvements we made and continue to make in performance. And then diving into ease of use. How do we make sure that we have a network that is really easy to use and drives innovation rather than starves the ability to move forward within your teams. And then finally, looking at some seamless integration with on-premise, sort of hybrid workloads. And so let's dive straight in. We don't have much time. Broadest scale and highest availability. I'm sure you've seen this slide at reInvent already a few times. This is our regions. We currently have 19 regions around the world. We've announced another 5 over the next year and a half or so. The one I'm most excited about is obviously the one down in Cape Town, which is my hometown, and where the early EC2 team actually started back in 2006. We layer on top of that our CloudFront edge locations. And so each one of those 150 dots that you see on that slide is an edge location where our CDN CloudFront can serve traffic from. These edge locations, the reason we put them out there is to make sure that we're as close as we can be to the various networks on the internet. Obviously, all over the world, there's various networks carrying traffic on behalf of customers, whether they're eyeball networks or other large networks. And we want to make sure that the Amazon network is as close to all of those networks as it possibly can be. And then each one of those locations also has really good dedicated capacity back to all of our AWS regions to make sure that we can carry your CDN traffic back to a region in the very best possible way. On top of that, we're going to layer Direct Connect. Direct Connect has 89 locations. Direct Connect provides private connectivity from your on-premise location or branch office, whatever it might be, data center, to AWS. So similar to an MPLS type of architecture. And once again, those are all located at our edge locations with really, really good connectivity back to AWS. So let's draw in the backbone. This is the AWS backbone. It spans the globe. It connects all of our regions. Each one of those lines is at least 100 gigabit network fiber. In many cases, it's multiple fibers, many terabits of capacity. And that's completely private network capacity that's for AWS use only and carries all of our customer traffic between regions. The other thing that's really interesting is this network is not a network that we had lying around before we started AWS. It's not something that Amazon used back in the day. It's actually something that's been built specifically for the cloud, and we continue to iterate on it. It's also prioritizing our customers' traffic. There's no other traffic that we have on our network that we would prioritize over anything that our customers are doing. And so tuning this network and keeping it highly available, low latencies, predictable performance for our customers is one of our highest priorities. So why do we have a backbone? Why do we need a backbone? The most important thing is obviously security. We want to make sure that your traffic is flowing on a network that we can trust between our regions. And we're at a point today where all traffic, we've been here for some time actually, all traffic between AWS regions, when you send traffic to another region, an endpoint in a region, travels on the AWS backbone. Obviously, availability, super important, right? We have very little control if it's a third-party network out there. If it's an AWS network, we can have great visibility into that. We can monitor it. As soon as we detect an issue, we can take mitigating actions to make sure that we fix any sort of packet loss that you may be experiencing. Then obviously reliable performance. Not quite the same as availability. Those of you that are into networking know just what impact jitter can have, or unpredictable latencies. And so making sure that our network is tuned for the workloads and you get the most predictable performance at all times is super important. And then obviously connecting closer to our customers and your customers. Many of you are building applications that have users all over the world, and we need to make sure that our network is as close to them, and we have the very best fiber to carry those packets back to the region that you may be in. The other thing we do is we spent a lot of time building this network, and that's something that I don't believe is ever going to stop. As AWS continues to grow, we need to keep adding network capacity at all times. The other reason we add capacity is to make sure that we have the best possible path. We might find that a certain path, let's say from somewhere in South America through to Europe, there may be a faster cable. We may be able to put a cable down that gives us a few, let's say 5 to 6 milliseconds of improved latency, and we would be looking at putting that in place. The final reason is obviously redundancy. We may decide that we need an additional cable. We may have a fishing trawler that comes along and damages a cable under the sea, and then we're down to one cable. And so we'll often add additional cables to make sure that we have enough redundancy to carry our customers' workloads. And so we've been speaking about 3 recently, and if we move over to the Pacific there's 3 cables that we've actually spoken about. One of them, the very first one, Hawaii, is actually live. We started that project about a year ago. And obviously, have a ship that goes across the ocean and lays a cable. It landed on the beach in Pacific City on the east coast, or the west coast of the US, sorry. And that is actually, we lit up the cable, and it's actually taking AWS traffic. And so that's giving us another connection from Sydney through to the west coast of the US. There's 2 that we're currently working on. One is Bay to Bay Express, and that's taking traffic from Singapore, again, to the west coast of the US, and it's just stopping off in Hong Kong along the way. And then finally, we have Juniper. And this is Jupiter. And that's going from Japan over to the west coast of the US. And so a lot of investment. We have a lot of other cables as well, all over the world, and those are the 3 that we're talking about at the moment. Obviously, having a backbone is useless if our customers can't use it. And so we have a number of services that allow you to use the Amazon backbone. First one is obviously Amazon CloudFront. We spoke about that a little bit. And then you have Direct Connect, and then inter-region peering, allowing you to peer between VPC regions. And so let's do a bit of a deep dive there. CloudFront is obviously a content distribution network, and so you would have a service hosted in one of our regions. You would sign up for CloudFront, and they would start advertising your application or your endpoint from each one of their 150 points of presence around the world. And so a customer that might be in South Africa is able to hit the local CloudFront POP either in Cape Town or Johannesburg and get really good connectivity back to your service in Dublin or US East 1, wherever it might be. The growth in CloudFront is impressive. They've added 50 new locations this year. At the end of last year at reInvent, they had 100 locations, and now we're at 150. And so it's just this massive expansion of the backbone. They also added the ability to fail over on the origin, just for improved availability. And then the last item on the list, they've got a Lambda at the edge. So you can actually run Lambda at each one of these edge locations on CloudFront. So you may have a request coming in, you want to manipulate some headers, you want to do something to that request, but you don't need to take it all the way back to the origin to do that. You can actually do it at the edge in Lambda. And so they've added a number of features there, including S3 origin support as well as request body access. Direct Connect's a similar story, obviously private connectivity, and yeah, they've added 12 new Direct Connect locations. They also added support for jumbo frames. I don't know if any of you saw that. It came out about 4 months ago. We've had jumbo frame support. In EC2, a jumbo frame is 9,001 bytes. We chose that number many, many years ago. But customers have said, hey, we've got applications that run on-prem, and we want to be able to connect to our EC2 instances and do jumbo frames. And so we added jumbo frame support over Direct Connect. And so those applications that were previously blocked because they didn't have jumbo frame support can now run on Direct Connect. And then we worked with VMware as well to make sure that NSX, their network, can actually run over Direct Connect. And so customers using VMware Cloud on AWS are able to get a very native, VMware native networking experience. And so a lot of good progress in Direct Connect. Inter-region peering, this was the one I was excited about last year, and I think a lot of customers were as well. Finally, we had inter-region peering, the ability to connect between two private VPCs in different regions and peer them up. And so region A can communicate with the VPC on region B using private IP addresses. It's all flowing on the Amazon backbone, and not only is it on the backbone, but all the traffic is also encrypted and anonymized. And so you're really guaranteed that traffic that you're sending from your private VPC over to the other VPC is really well protected. The team, when we launched, I think last year, we had maybe 2 or 3 regions that were supporting inter-region peering, and we added all the regions in sort of the first half of this year. And then also added support for DNS resolution, network load balancer, and private link, really just making sure that all of our different networking options work on inter-region peering. And so those are the services that use the backbone. But some of you may have seen this week, there's actually one more. Global Accelerator. This was announced on Monday night, and Global Accelerator improves the network performance of your application by advertising an IP address at the edge of our network globally for your application. And so you may have an application hosted in the US East 1 region, and using Global Accelerator can actually assign a single IP address to that load balancer, that EC2 instance, whether it's a network load balancer or an application load balancer. And that IP address is advertised at every one of the 150 locations globally. And so a customer accessing that IP address will automatically be routed to the closest location using Anycast, and then use the Amazon backbone to get back to the region. And so you can see how this works. So accessing an application, obviously, it's not that straightforward. There's a whole lot of networks involved. And so here we have a local ISP, and we have a whole lot of networks, intermediary networks, before you get to the AWS region. What often happens, as I said, is you can get jitter, you can get performance issues, you can also run into latency, and sometimes you can even see packet loss. And so what we want to do is we want to find a way to get rid of those networks in the middle there. And so with Global Accelerator, by advertising our network, your service at the edge of our network all over the world, your customers are now able to access AWS directly, and the only network after their ISP is the Amazon backbone. And so we're pretty excited about this one. We think customers are going to see improved performance, and so interested to see what you do with it. As I said, it's a single IP address globally. It's a redundant network paths. That's one thing that we've done that I think is a little different from what you may have seen from other cloud providers is when we think about availability, we're always incredibly paranoid to say, where could this possibly fail? And so while other cloud providers might give you a single IP address, we actually provide you with 2. You're happy to use one of them and just have the other one as a failover if something happens, but each of those IPs is actually tied to a different network path on our side, guaranteed not to overlap. And so we know that if anything happens on one of the paths, there's another path that you can go and use. You can target EC2 instances and load balancers. We'll be adding other services over time. And then it's also incredibly easy to set up. The other thing it really does is simplify multi-region. And so if you want your application to be hosted in multiple regions, you can use Global Accelerator to just set up and target multiple load balancers across those regions. You can set it up so that if your customer happens to be closer to Europe, it would route the request to the Dublin data center. If it happened to be in the US, it could route the request to our Portland data center, wherever your application might be. And so it's got dynamic routing and error detection built in. Pretty excited about that one. So that's the backbone. Let's take a look. The other part of this section was obviously availability. And so how do we think about availability of our network and our backbone? I wanted to share a few things here. We have this saying internally called "There's no compression algorithm for experience," and I think it's really sort of comes from the sort of culture that we have inside Amazon. Amazon doesn't have a blame culture at all. If you break something, the first thing we all try to do is learn from it and what happened. And we don't have a blame culture because we want somebody to be able to say, this is what we did wrong, and we're not going to blame anybody because then we're going to learn as much as we possibly can to make sure it never happens again. And so coming out of that sort of focus on learning every single time we have a problem, over the years we've learned an enormous amount sort of from mistakes we've made about how to run a network. And so that's where there's no compression algorithm. And so if we look at our, this is a region, so this would be like one of our US East 1 or US West 2. And so it's made up of a number of availability zones. I think you've heard a lot of talk around availability zones and just how we think about these zones. These are separate buildings. An availability zone will always be at least one building. It could be multiple buildings. I think our largest is about 13 buildings. And they all link together with fiber. In one of our largest regions, we have 388 unique fiber pairs linking up all the various availability zones and transit centers, carrying 4,947 terabits of bandwidth. Whoever knows anything about networking, that's a lot of traffic. And so a lot of focus in making sure that everything is highly available. This is some of the progress. When you have that much fiber, it becomes incredibly important to make sure that we reduce costs. And so this is some work we've been doing with some of the fiber manufacturers. This is a piece of optical fiber we've been using for the last few years. And it has 3,456 strands inside that cable. And so we said, well, one of the ways to reduce cost would be to put more strands inside the cable. And so we worked with one of the providers. We actually managed to get exactly double that, 6,912 strands inside the same 2-inch diameter piece of cable. And so that means now we can carry twice the amount of fiber inside that cable and obviously reduce our costs significantly. There is one other fiber that we have. This is an interesting one. This is optical fiber with the termite-resistant coating. And we only use this in the Sydney region. That's what the blue coating is. The other thing we say is everything fails all the time. It sounds horrific. We don't actually mean that it fails all the time. What we mean is we need to be thinking like it's going to fail all the time. And so when you build something, we always say, well, what could fail? And when something does fail, how's our application and system and network going to respond to that? How do we make sure that there's no customer impact? So I want to show you guys a few things just so you get an idea of how things fail. So this is a construction worker that came across one of our cables with a backhoe. So this was in, I believe this is one of our US regions. And so, yeah, we have a construction site where a backhoe has dug down and found some optical fiber and obviously gone through that. Now, there's no way that light's going to travel through that fiber anymore. And so that fiber is no longer in service. In this case, actually, some of the work we've done in terms of optical failover. So we've got redundancy, and when a cable fails, we actually detect it at the optical level. And by doing that, we don't have to worry about route convergence. And so at the optical level, we were able to fail this traffic over to another piece of fiber, and we dropped 13 packets, 1-3, which is pretty impressive given the scale we're running at. This one's a little more interesting. This is in our Sao Paulo region. And in Sao Paulo, they don't put a lot of cables under the ground. Everything goes up on the street poles. And so, yeah, we have a dumpster fire. I don't know what happened to the dumpster, but there was a fire there at the bottom of that pole, and it ended up burning all the cables at the top of the pole. In this week, I believe we actually had about 3 fiber cuts in that same region, all with no impact to customers because we've built in the redundancy into our system. And so this is just a normal thing for us. We've got so much of this fiber, it is going to fail. We've got to be able to handle it. And so obviously what we do is we have dark fiber spans. We've got a lot of dark fiber available, so when we do have one of those problems, we can shift traffic and then automatically mitigate. And normally we can bring up another piece of fiber within about 2 to 4 hours, just to give us that redundancy again, and it normally takes a day or 2 to actually get the fiber repaired. It's all Amazon controlled. It's super important. We have to have control of the fiber to make sure that we can route that traffic correctly. We also use geospatial coordinates, so we actually know where all of those fibers are. And then we run machine learning on that for a few things. We want to know if 2 pieces of fiber are too close together. Just given the scale, we want to be able to find out if a piece of fiber is within a meter, let's say, of another piece of fiber, well, that backhoe could probably go through both of them, and that's a problem for us. We also run simulations to try and understand if any piece of fiber failed at any point in the network, what would the impact be? and then running models to understand, are we actually going to be able to mitigate that and identify potential problems before the fiber breaks and we learn about it the hard way. And then obviously multiplexing. So we do have the ways to vary the wavelength within the fiber to actually increase the capacity of the fiber over time without needing to put new fiber in the ground. And so that's a lot about our regional availability, sort of within a region. I wanted to talk a little bit about our global availability and how we think about our global network, which is actually pretty unique. And it all stems from sort of when we first built EC2, the second region, which was Dublin, back in 2008. And we made a decision back then to have, firstly, strong isolation between availability zones. We can't stress that enough. We make sure that no two availability zones can fail for the same reason at the same time. And that means when we do deployments, we don't ever touch two zones at the same time. When we build our systems, we make sure that they're isolated within those zones. It's super important for us to be able to stand over that. All of our cooling systems, network, everything is completely separate between zones. More importantly, though, that I think is even more critical is strong isolation between regions. And this is something that, as I say, we learned a lesson in 2008 before we put the second EC2 region down. And as a result of that, we decided that we would never, ever share any data between regions. Because if I'm sharing data between regions, there's no way that I can guarantee that two regions won't fail for the same reason at the same time. And so we actually have systems that monitor service teams. And if any service team is caught sending data between regions, they'll get a high severity ticket. They'll get paged immediately. And so that's the level that we run at, is we need to guarantee that for our customers, no two regions will fail for the same reason at the same time. In other cloud providers, that is not the case at all. They actually advertise the fact that they have no isolation between regions. They talk about things, a global network. And they say, hey, we have a global network. Our VPC is scoped to a region, and you can use things like inter-region peering to be able to give you global network functionality. In other providers, it's a global resource that, one is obviously data sovereignty, you need to be careful there, but the other one is obviously from an availability point of view, things can fail for the same reason at the same time, and that's what we've seen. And so AWS is actually the only cloud provider that hasn't suffered a global network event because of the strong isolation that we have. We're certainly not comfortable in that. We remain paranoid at all times, assuming that something could happen, but our architecture has been designed in that way to guarantee that you can rely on the availability of regions. And so let's move on here and talk about some of our security features. One of the things many, many years ago, many companies were worried about cloud security. This is a quote from Capital One that we really, really like, where they actually say that they're more secure in the public cloud than they would have been in their own data centers. Obviously, Capital One has moved in a big way onto AWS. And so just the breadth and depth of the security features that we have available across the services. If we look a little bit more in sort of a couple of the key ones in the compute and networking space, one of the ones I wanted to just briefly draw your attention to is Resource Access Manager. That actually launched last week with a networking feature that we'll talk about a little bit later on. But this allows you to do sort of cross-account sharing of resources. And the one that was announced last week was that you'll be able to share Route 53 domains between accounts, the management of those domains. But you're going to see us use this feature a whole lot more to do cross-account sharing of resources within EC2, the various objects that we have. Let's touch a little bit on virtual private cloud. Obviously, very, very secure. It's been designed, when we designed the software-defined network that powers VPC, we made sure that it was super secure. A lot of the things that plague normal networks, like being able to spoof IP addresses and things like that, those packets just get dropped on the network. They're not even allowed to leave the guest. And so if you try to do that from an instance, it wouldn't work. And so we get a lot of security from that. Obviously, you know about security groups and ACLs and NAT gateways and flow logs. And there's really been a shift. If any of you are looking to build VPCs today, the big shift has been moving away from using IGWs and NAT gateways and really running private networks. And so when you run a private network, then you don't have any way of communicating outside of that network. And so you're looking to use things like private link, which is the ability to call AWS services from a private IP address within your VPC, or use VPC endpoints to talk to S3 and DynamoDB. And so a lot of customers, big shift in that direction. I want to touch on elastic load balancing. There have been some interesting features here in the security space. It's, again, our elastic load balancing product. We have 3 load balancers, the classic load balancer, the application load balancer, and the network load balancer. You'll notice on the slide behind me, classic is grayed out. Little tip is if you see the word classic, it probably means there's a brighter and newer option available that you may want to consider looking at some point. And so, while we continue to support classic load balancers, we're not going to be adding any new features to them. But application load balancer and network load balancer are feature-rich. We'll continue to add features. We've got a lot more features even before the end of this year coming to many of those load balancers. And they're also cheaper than classic load balancers. So it's really good to think about migrating. One of the biggest features we actually added this year, and I'm sure some of you were happy to see it, was support for redirects and fixed responses in Elastic Load Balancer. I think it was probably our most asked for feature, and as you would expect, after we launched it, it's been our fastest growing feature on Elastic Load Balancing in terms of adoption. A lot of things, yeah, slow start support, being able to bring out backends, just a really strong year. On the security side of things, Elastic Load Balancing, putting a load balancer in front of your application, an application load balancer, really provides you with a great level of security in a number of areas. And so you can offload your TLS, your SSL to that load balancer. We also support SNI, so subject name identifier, which allows you to host multiple SSL certificates on a single load balancer. And so that, together with host-based routing, means you can start to collapse your load balancers. You can go from multiple load balancers that you had maybe for 10 customers, go down to one load balancer, and you can put everything on a single load balancer, which saves a lot of money. And then obviously access logs, which is detailed logging of every single request. And then application firewall, which is a web application firewall that allows you to, to do things like block certain IP ranges or to put in mitigations for certain headers that might be in the request. The one that we're super excited about actually launched earlier this year, user authentication. And so with Application Load Balancer, you can now go in and very quickly set up, maybe you want to support Facebook login, or you want to support Active Directory, you want to support some other OpenID provider. You just go in and configure that in the load balancer, and Elastic Load Balancing will automatically receive a request, realize that it's not authenticated, go through the whole login process without actually involving your application at all, and then once that's completed and the user's logged in, we'll actually send the authenticated request to the back end, and your application can just read the headers. And so if you think about supporting auth, whether you've got an OpenID Connect system within your organization or you're using some third-party federated login, Application Load Balancer can do it all for you now, and you no longer have to put that kind of boilerplate code in your backend instance. And so really nice feature. And then the final section I wanted to touch on here was Private Link. We launched Private Link last year at reInvent. Private Link allows you from a VPC to host a service behind a network load balancer and then share that service with other VPCs that are completely private. And in those other VPCs, an IP address will appear that's within their CIDR range that they're able to talk to communicate with your service. And so it's a little different because I don't think we've seen anything like this in traditional networking. And but we started to see, as customers have started to realize the value in it, that we've started to see it really start to take off. I had one really interesting conversation with a bank, one of the big East Coast banks, who were thinking about redesigning their network, and they actually came out to Seattle and brought their network design to us. And then we took a look at it and we said, hey, well, have you heard about Private Link? And after about 3 hours of conversation, they'd redesigned everything to go and use Private Link and go with VPCs that are much smaller and then be able to share them between their developers. And so we also seen customers such as Salesforce and Snowflake and those customers at the bottom start to use Private Link in terms of offering these SaaS services to customers. And so in the case of Snowflake, very often customers are, they're trying to communicate sensitive data. They don't want that data to be on the internet. And so with Private Link, Snowflake is able to put their database in your VPC. And so when you talk to their service, your data is never going on the internet. It's talking to an IP address that's within your VPC and then being routed automatically to their database service. Obviously, we have a lot of partners from Trend Micro to F5, Aviatrix, Splunk, a whole lot of providers in our marketplace. It continues to grow. It's actually one of our largest sections of our AWS marketplace is the networking and security section. So let's talk a little bit about world-class performance. And there's a couple of new things we've done. And so we showed you this last year was the progression of network performance at the instance level. This is something that we always focused on. We're always looking at how do we get the next step in packet per second. How do we get the next thing in terms of lowering latency? And there you can see the progress we've made, right? We were pretty happy with 1 gigabit back in 2008 on the C1. We thought we were great with the 20 times packet per second and enhanced networking on the C3 in 2012. Last year at reInvent, we announced the C5, and that did 25 gigabits per second and less than 50 microseconds of latency, which was great. And this year, we've actually just announced 100 gigabit networking on C5N. And that was launched on Monday night, so you can go launch a C5N right now and test out 100 gigabits. That'll also give you 100 gigabits between instances, but also from S3. And so if you have any workloads that really are network hungry to get data from S3, you're able to use that for C5N. So C5N is pretty much the same as C5. We just added the N to indicate networking. So it's a high-performance compute. We did change the memory footprint a little bit. We noticed that on C5, some of the HPC workloads didn't like some of the bimodal metric memory performance we saw, and so we've given you a little bit of an upgrade on the memory as well. But then it's really the 100 gigabits of network performance that we're really excited about there. And so you also, on the smaller instance types, you get 25 gigabits burst bandwidth. And so we're really just removing the network as a bottleneck. This is all powered by a Nitro hypervisor, which we've spoken a lot about in the past, and something we built over the last 4 years and really allowing us to do this. The other one we did was very similar. It's also a new instance type, P3DN. This will be available next month, but also 100 gigabits of networking together with the GPU. And so a number of customers are using P3 for a lot of inference workloads and a lot of large clusters. And one of the bottlenecks has been the network. 25 gigs with 8 Tesla GPUs is really not enough to kind of share that data. And so now you can get 100 gigabits within that cluster. And so, incredibly powerful instance. We're seeing improved latencies. So across the board for the 100 gig instances, you're also getting well less than 50 microseconds. But we said there must be a way that we can actually improve that a whole lot more. One of the things that adds to latency within our network is obviously TCP and some of its congestion controls. And so we took a look at that and said, could we build a protocol, sort of a datagram protocol that actually avoids some of those problems? And so we built a new protocol, and we're exposing that to you as Elastic Fabric Adapter. And this is currently in public preview and will launch over the next few months. But Elastic Fabric Adapter, together with a C5 or a P3DN, allows you to get as low as 15 microseconds of latency. And so this is really, really targeted at your big sort of HPC-style workloads, where that sort of latency is critically important. Now you can get 100 gigabits and 15 microseconds of latency, which is really, really good. This is the section I'm honestly most excited about, is building a network that is simple and easy to use. This is a quote that I've liked to say. I thought it was kind of funny to put my quote up there. The network should not slow things down, but rather promote innovation. And one of the things I've seen over the years, and I'm sure you've seen this within your own data centers, is very often you've got your networking team that build and manage the network. You've got a development team that write applications, and they don't typically talk to each other until about 3 days before they have to launch something. And then they need to work out, how do we open up firewalls, or maybe we don't have enough capacity, or we didn't order a load balancer, or whatever it might be. And so networking hasn't really been something in the past that's really promoted innovation. And so one of the things we've been thinking about is how do we build a network that can actually promote innovation? And so some of the key criteria that we kind of set for that was, the first thing is it needs to have cloud scale. And so I don't want, cloud scale, if you think about S3, I write to an S3 bucket, I never think about how much capacity S3 has. Right, I launch an EC2 instance, I don't think about how much capacity EC2 has. The illusion of infinite capacity is cloud scale. And on the networking side, we want the same thing. We don't want limits that limit you to number of routes or number of security groups or those sorts of things. And so that's a big focus for us. The other one is cross-account. I know many of you have more than one account in your organization. Some of you don't know how they all got there, but it's a reality. Cross-account is something that a lot of customers are doing. I think it's a great model, honestly. I think using the account as a level of isolation is really, really good. We use that internally within my teams. And the network has to just be account agnostic. Let's make sure that all of your networking functions can work across accounts. And then the other one that I've been thinking about a lot lately is supporting the personas. And so what I mean by that is we have networking engineers and we have application developers and a whole lot of other folks involved, but really those are the two key ones we have to think about. In your organization or your data center network, your networking engineer is in control of that network. Your application developer doesn't have to think about the network at all, right? They go and build their application, and at the last minute they think about it. One of the challenges of that model is the networking team doesn't have a lot of visibility into what the application developers are doing until they come and ask. If you think about what we have in the cloud today, is we've actually taken that networking function and we've pushed it onto developers. And we said, okay, well, don't worry, it's actually quite simple. All you have to do is create a VPC, set up a few subnets, set up some routes, and then don't forget to add an IGW, and you should be good to go. it's not that simple for a lot of engineers, and they get frustrated by the networking side. And so one of the things has been, can we actually bring back this idea of I have a networking team that actually manages my network, and I have a development team that doesn't have to think about the fact that they're running on a network. I just want to launch an instance and run my application. And can I give the networking team better visibility into what the developers are doing? And then the other one is it has to be agile. There's nothing that frustrates me more than speaking to a customer that took some decision in the past and now they're struggling to move forward because of the decision they took 3 years ago. And so whatever we build, we have to have a system that based on decisions that customers are taking, obviously we give them guidance and should guide you in the right direction, that when we launch a new feature, you want to bring something else into your network at some point in the future, it just fits in and it's seamless. And so this is what we're targeting, this is what we want from the network, and so let's move forward. The first step we took in kind of achieving this vision was AWS Private Link. And so AWS Private Link gives you a lot of the cloud scale. It's CIDR agnostic. I can just, thousands of VPCs can use Private Link and share with each other. It works cross-account. VPC peering also works cross-account. It doesn't really solve the persona problem. Agile it's amazing on the Agile front. You can literally just have a CloudFormation template that gives every single engineering team the same VPC with the same CIDR, and they just use Private Link when they're ready to communicate between themselves. And so that was a big step forward. What we announced at reInvent, and this is something we've been working on for about a year and a half, super excited to announce it at reInvent this year, was Transit Gateway. So, big step forward for us. Transit Gateway is a regional construct. It goes into a region, so it's not part of a VPC. You just create a Transit Gateway. You can associate thousands of VPCs with the Transit Gateway. I think the soft limit is something like 5,000. Don't tell anyone I told you that. And so just massive scale. Like, those VPCs appear, just attach them into the Transit Gateway. The other thing it does is it'll automatically share the routes. And so you don't have to worry anymore about trying to set up that mesh with peering and trying to get all that routes. You just attach to a Transit Gateway, you route through to the Transit Gateway, and it automatically shares routes. Routing domains. So we added routing domain support. And the way this works is you can attach a separate route table to every single attachment. And so traffic from a VPC, you can decide should be routed, instead of going to the actual destination or the target, route it through another VPC and maybe go through a network appliance that's doing some sort of traffic monitoring. And when it puts it back on the wire, it's going to go to the original destination. And so ingress, egress, east-west with Transit VPC, you can do all of that middle boxing. And you'll hear from one of our partners later on just how they've been using this. We've also had a number of partners do integration. You can see Fuse at the bottom here made a statement. AWS Transit Gateway radically evolved and simplified cloud networking. Using Transit Gateway, we reduced the time to interconnect new VPCs and on-premise networks from weeks to minutes while attaining consistent and more reliable network performance. And so it's a massive step forward in terms of VPC topologies. Let me walk you through a little story here quickly. So when we built VPC, we didn't think anybody would have more than one VPC. The limit was literally one. You could have one VPC. And then some customer came up with a second VPC. I don't think they knew where it came from. Some engineer created it. And then they said, well, we need these two VPCs to talk to each other. OK, well, that's simple. Just set up a peer connection, right? And then suddenly there were another two VPCs. And so they said, well, that's simple as well. Let's just set up peering. And then they realized that that wasn't all they had to do, because that's actually not a valid peering configuration. You have to do the full mesh. And so they said, OK, well, everything's fine now. And then somebody said, well, let's add VPN. Great, let's add a VPN connection, we put a customer gateway, and we put a VPN connection down. The problem is that VPN connection can only communicate with the VPC that it's connected to. It can't get to any of the other VPCs. And so now maybe you want to go and do a transit VPC, and you put down a third-party appliance and do all of that. Or you could just connect your VPNs up to all the other VPCs. And that's great until somebody decides you should upgrade to Direct Connect, and then you have the same problem. So now you put Direct Connect in, you've got that VPC, you've got to set it all up. And so you see the nightmare taking shape. And so let's run the same story again with Transit Gateway. So you start off with one VPC. The second VPC appears. You decide to put down a Transit Gateway, and you link them up. You've got connectivity. Third and fourth VPCs arrive. You link them up. All of those VPCs can communicate with each other. You haven't had to set up anything. The routes are just automatically shared. You decide you want VPN. That's great. Let's put VPN in. That VPN connection has access to all those VPCs. And what's more is you can do ECMP on that VPN connection. So you can actually bond multiple VPNs together. I had my engineering team demo a 40 gigabit VPN connection to me the other day. It was pretty cool. And then obviously Direct Connect as well. Little asterisk on that, Direct Connect is not currently supported with Transit Gateway, but we expect to launch it in Q1. And so if you start playing around now, hopefully by the time you're ready to deploy, Direct Connect's there. So if we look at the Transit Gateway, it's pretty cool. I mean, we get the cloud scale, right? Thousands of VPCs, shared routes, edge consolidation. It's completely cross-account. It's super, super agile. And we're going to make sure that all the stuff we launch integrates with Transit VPC. The one thing it doesn't really solve, though, is personas. I still have, like, who owns that Transit VPC and who's launching those instances? And so today I'm happy to announce shared VPC. So easily share VPC networks between AWS accounts, providing central oversight and control for networking engineers. And so the way shared VPC works is, on an account, I can set up a VPC, and I can share, and I create a few subnets, and I can share those subnets with another account. The other account, when they do a describe subnets call or they look in their console, they just see the subnet that you shared with them. They don't see any of the other networking information. But all I need to launch an EC2 instance or create an RDS database or use any of the other services is to use the subnet. And so they simply just put the subnet in and they can launch an instance. And that instance lands in the VPC that you set up. And so if we think about network engineers, now you have a team that owns an account that has your VPC configuration, your VPNs, your Direct Connect, your security groups, your ACLs, everything related to networking. They create VPCs and they just share the subnets with engineers. Engineer doesn't need to know anything about networking at all. All they need to know is how to launch onto a CIDR, or onto a subnet range, right? Just launch EC2 instances, pick this subnet. And so developers are now no longer have to worry about setting up and creating a network. And then also you get edge connectivity, because instead of having separate VPCs in all these accounts, you can now consolidate them. I think it's an incredible feature. The only advice I have for you is, I think used in conjunction with something like Transit Gateway or peering with a number of small VPCs, where those VPCs are still sort of have specific use cases, rather than going for a model that says, hey, let's just have one VPC and put everything into that. Amazon actually tried that. It became a little unwieldy on the retail side, one very, very large VPC. And retail, they've actually moved now to a model with private link and smaller VPCs. And so I think it's an incredible feature. We're super excited. And so if you come back to this vision of cloud scale, cross-account, having the right personas and being agile, I think with private link, Transit Gateway, and shared VPC, all of which are available right now, I think we've taken a big step in the right direction. And so to talk a little bit more about this, please welcome Sherry Wei, who's the founder and CTO of Aviatrix, to talk a little bit more.
Thank you, Dave. It's an honor to be here. You just heard from Dave that if you have a large number of VPCs, TGW significantly simplifies the VPC connectivities. But you can't stop there, because you see, if you have one connected VPC, you have a blast radius or attack surface of your entire network. So if someone hack into a one VPC, he or she can make lateral movement and eventually compromise your production data. And in fact, there's a study show that 99% of data breach happens from a weakness in the network design, that is lack of segmentation. The great news is that TGW offers more. TGW has these two new constructs called route domain and route domain propagation that makes it possible to build secure networks. So what do we do in Aviatrix? We created a TGW orchestrator that builds on the capabilities of TGW. We create a security domain and abstraction called security domain, which allows you to build isolated network, and then with the security domain policies, allow you to connect these isolated network together by policy and intent. So together, you can build a secure segmented networks while benefiting from simplicity of networking. And all the while, Aviatrix Orchestrator does all the route table updates and route propagations so that you do not have to worry about any of the touching any of the routing tables. So let's take a look and see how it works. The Aviatrix Orchestrator is a function in our Aviatrix controller, which is available in AWS Marketplace as a metered AMI that you can launch. You launch in a VPC, and then your security team works out the design of your networks. Say, in this case, we want to have a prod domain, security domain, and we also have a dev domain and a shared service domain. And our policy says both dev and prod can talk to shared service, but they cannot talk to each other. So once you have your domains, you designed it and have your domain set up and connection policy set up, the next thing you do is you simply attach these VPCs into its respective domains, and routes will be built, packets will start to flow, and in this case, prod and dev cannot communicate with each other, but they can talk with shared service. Next, about the edge. We extended TGW to support, which extended TGW function to support Direct Connect out of the box. So Direct Connect customers today can benefit TGW and migrate to Transit Gateway and build secure networks. It's available today. And well, we take care of propagating the on-prem routes all the way to the spoke VPCs and between the spoke VPCs and ensure the security is properly set up. And you can do this over and over with the VPCs. You can set up thousands of VPCs without ever having to touch the route tables and let the Aviatrix orchestrator do the magic for you. And we can do more than that, not just plan and build. We can also view and validate so you can see what you have planned and if you have planned correctly. And you can validate the troubleshooting and see what is built. And we have auditing capability to see if you have built it correctly and if there is any violations. So in summary, I believe that TGW is a significant step forward in achieving network simplicity and security. And Aviatrix Orchestrator makes it all happen, makes it all possible. Your security team can build the policies, design the policies, and your networking team build the networks, and your ops team run it, all in one happy family. And the best is it's available today. Thank you. Thank you.
Thank you.
Thank you.
Been great working with the Aviatrix team. When we showed them TGW, Sherry sent me an email. It was so excited and gave us such great feedback that I just thought we had to have on stage to kind of talk about what they've been doing. They actually launched their product yesterday, together on Monday, together with TGW when it launched. So thank you. Okay, last section, supporting hybrid architectures. So let's dive in there. And so it's critical to provide a seamless network experience between on-premise networks and AWS cloud. You know, one of the things we think, as we've seen, there's going to be workloads that aren't yet in the cloud. You've got data centers, and you may be planning to move some of those workloads to AWS over time. But there may be some workloads that stay in the data center. You know, there may be workloads that are close to data, it's located in the data center that you don't want to move. There may be stuff like branch offices, or maybe your location is somewhere where you need low latency, or latency is very sensitive, or near some sort of hardware that there's just no way you can kind of move that into AWS. And so we want to make sure as a cloud provider that we provide excellent support for that on-premise workload as well. There's a couple of things we want to talk about here. Firstly, I think most of you know the space. So we have AWS Direct Connect. We spoke about that. We also have site-to-site VPN, which is really from your data center to AWS. And then one you may not have seen is Route 53 Resolver. This launched about 2 weeks ago. We had a number of features. reInvent was just so packed. We had a number of things we said, if anything can go early, let's ship it early rather than have any more stuff in reInvent. It's a good problem to have. And so we launched it about 2 weeks ago. And so what this does, if any of you have been trying to run Route 53 or access Route 53 from your on-prem, you can do that with Route 53 Resolver. And so what customers have been doing is having to run their own resolvers and do forwarding, and then those resolvers fail, and there's a resolver per VPC, and it's just it's a nightmare. With Route 53 Resolver, you set up Route 53, you just set up the forward domains from your on-prem, everything gets forwarded, you have split horizon DNS. If you're inside a VPC and you can resolve, or if you're on-prem, you can different IPs. And so it's excellent service. I think takes away an enormous amount of the pain. It's been available for about 2 weeks, so go and play with it. And I spoke about all that, and there's the slide. And let's come back to this one. So, client VPN. This is going to be available in the next month. So client VPN, unlike site-to-site, which has to come from a data center, client VPN allows you to connect from any device, anywhere, to your VPC. That traffic within the VPC can also route to any resources within AWS. If you decide you want to use that traffic over Direct Connect to get to on-prem, you could absolutely use AWS as the client VPN provider. Secure access, and so access to resources on AWS via a client VPN, or as I said, on-premise as well. Any device that supports the Open VPN client, this is a fully managed service, and so you literally log in, create a new client VPN endpoint, define some things about your users and how you want your authentication to work. Maybe you want to use Active Directory or certificate-based authentication, and then you start to provision your clients. And so from your mobile phone, you'll be able to connect into resources or get VPN access directly into AWS and VPC. And as I said, integrated. And so that's going to be available in the next month, before the end of the year. And so that really sort of completes our hybrid story. There was one more thing that you may have seen this morning. We've been working on the Nitro system for quite some time. I mentioned it earlier in terms of how much progress we've made in network performance because of Nitro. And one of the things we realized with Nitro was, well, some customers have been asking and saying over time, hey, is there any way that you could actually put AWS resources or AWS servers within my data center? Is there any way that I could have an AWS server in my data center, running in some sort of form? And we were always a little worried about it because we didn't like the idea of having something that's disconnected from AWS. One of the big value adds of AWS is everything is automated and everything's done via APIs, and we're keeping the software up to date, and you always get in the latest features. And if I build a rack and ship that off, well, now that rack starts to become out of date, right? If I can't put software onto it. And so with Nitro, the work that we've done both at the hardware level as well as at our control plane levels actually allows us now to put a rack anywhere and still have it connected to the cloud. And so this morning, Andy Jassy announced AWS Outposts, which is the ability to run key AWS services on AWS hardware within your own data center. And this is shipping later next year. There's an example of what a Nitro rack would look like. So this is the same hardware in a slightly different form factor, but the same hardware that we would actually run within an AWS data center. And so you could order a C5, an M5, an R5, to get the physical hardware with all of the Nitro cards and everything in that box, and have that shipped to you. You'll be able to put it in your data center. Literally all that's required is to plug it in. Once you've plugged it in, you need some sort of connectivity. You don't need a lot of connectivity for the control plane to work, VPN connection, direct connect. But you would actually go to EC2, and that rack is going to be part of a subnet that you choose in a region somewhere. And so you register it and say, this rack that's in my own data center is now going to be part of this VPC that's hosted in US East 1. And so when you launch, you go to the console and you target US East 1 and you say launch in this subnet, and a new C5 instance will land on your rack in your data center. From our point of view, it's still part of our availability zone. When we do updates, when we do software updates, when we add new features, it just gets deployed automatically. And so it's a fully managed solution. We're also monitoring it. And so all the normal monitoring that we have for our hardware in our data center would absolutely work on your data center. And so any things like degraded drives, we'd be able to take them out of service and monitor them. If something does fail horribly, it's simply ship a new server, you pull it out, you put a new one in, and you're ready to go. The use case here is really, again, for some of those workloads that you may never, for whatever reason, latency, large amounts of data, be able to move to the cloud. But you really want to have the same experience and the same hardware as you get from EC2 within your own data center. Other things might be, processing a large amounts of network data, network function virtualization, that sort of thing. we'll be able to ship any of our instance types on this, including GPUs, FPGAs, and so it really is EC2, fully functioning EC2 on a rack that you'd be able to put in your data center. And so we're very excited to announce this today, and a lot of hard work to launch it later this year. And so with that, we've covered an enormous amount. We've got through it quite quickly. Happy to get through all of that. So looked at a lot of the scaling, security, world-class features. The section I said I was most excited about is just the transit gateway, the shared VPC, and private link, really going after that new vision for cloud networking that says, let's make sure that we have a persona for the networking team that can build and create VPCs using features like TGW, transit gateway, to set up topologies that are really going to be able to scale with your organization, and then developers that no longer need to have to worry about all the networking details, but can really just launch EC2 instances into subnets that they've been provided. And so we're pretty excited where that's going. And then obviously Outposts is another highlight for us. And so that's a list of everything we've spoken about today. Everything that's been announced within the last few months that you may have missed was on the left-hand side. And then obviously the features that we've covered in this. The two new features that we announced were shared VPC and client VPN coming later this month. And so with that, thank you very much.